Alright. Good morning, everyone.
Good morning.
Alright, so like I said, it took me a long time to kind of hone down which activity I wanted to do, but finally landed on one. And essentially the purpose of it is to understand the concept of light refraction. So we'll do that by making ovens out of cardboard and aluminum foil. Okay. Alright, so my lesson plan ended up being a lab write-up, or the format of a lab write-up. So the materials that I would allow the students would be a cardboard box of any sort, like a shoe box of something, a sheet of black construction paper, 2 graham crackers, a marshmallow, a bar of Hershey's chocolate, scissors, stapler, timer, a thermometer, a sheet of aluminum foil, tape, glue, ruler, and whatever else they may need. So you'll be making ovens, but they'll be making s'mores. So there's a little bit of a treat at the end. Alright, so the reason that there are so many materials allowed is because I wanted this to be more of like a trial and error type thing. So I wanted the students to be able to, take whatever cardboard box that they had, use that as their foundation, and kind of figure out what would be the best way, the most effective way for me to make an oven, like a solar oven that would function optimally and give me s'mores in the quickest amount of time. So they would have a timer, and they would enter in the time the time elapsed between having a completely dry set of graham crackers, marshmallows, and bar of chocolate, and the melted one. So, and there would be a little bit of a competition. So that's just a little bit of it. And so essentially, the procedure that I said was that the students can do whatever they wanted with it. That they could, because I feel like being able to understand light refraction would just get really boring if you were to just look in the textbook and say, okay, electrons bounce off of the aluminum foil into something that absorbs heat, something like that. That would be really boring. So I wanted a hands-on experience for that. So the procedure, it'll vary. It's whatever the students want to do. So that's just kind of, and then I had a conclusion at the end. So it would be certain things like what worked well, what didn't work well, maybe diagram your design, what might you have learned about the relationship between the tinfoil and the cardboard and the black construction paper allotted. I find that, I've done this experiment before, and I found that using staples as opposed to glue or tape works a lot better, because glue and tape somewhat insulate the entire device, and you don't want that to happen. You want it to melt as quickly as possible. Lining the entire box with black construction paper is also something that would be very beneficial, because light not only reflects off of the aluminum foil, but you want a way to get the light to reflect off of the aluminum foil and into the box so that the black construction paper can absorb the heat and surround the s'mores. So that was my idea. So this would be something you can literally use in any science class. This is a very basic science concept that light particles or photons will bounce off of a surface like aluminum. So you could use it in biology when you're trying to explain how electrons move around from photosystem to photosystem in the processes of Krebs, or the ETS cycle, if you all remember that from biology. You could use it obviously in chemistry when you're studying things like the Tyndall effect. So it's just something that I felt was very basic, but it was kind of a nice intro to be able to ease into one of those more taxing, more difficult concepts.
Good. Wait, you're not done yet. You're not done yet. Now here's the fun part.
Not done?
Yeah, you could lead us in a brainstorming session. I'm curious what questions you have, such as what if it's a cloudy day, or because you're doing sunlight-based, a solar oven, right?
Yeah.
So like practical questions or sequencing questions, like this is a really good idea. Where does it come? We talked a little bit about support and challenge. Do you use this as a provocation? Like do it early in the curriculum so that they start, why does it heat up? And then you look at the theoretical foundations after it. What kind of questions do you have about sequencing, practical considerations? Go.
So I like the idea of how you gave it the procedure to be open so they can do whatever they want. But if depending on what age group you're working with. Like some of the kids might not know what to do. But like I understand like if you're gonna work with high school, they should.
Yeah,
Age group,
this,
but
yeah.
age group is
My
okay.
audience was intended to be high schoolers.
Yeah, so that was good. I was just.
Yeah.
Be good.
Have you, I'm sorry, have you thought about, just to follow up on the same kind of question, have you thought about how you could tweak it so that a middle school teacher could use it?
Well, I think it is open to middle schoolers. The only thing fuzzy would be elementary schoolers doing it. I wouldn't trust them with that. But I think middle schoolers can do it easily, as in the teacher might have to give somewhat of a model, like certain hints to say, by the way, the black construction paper absorbs all the heat. Or, you know, the aluminum foil, it heats up really quickly, so you might want to put that near something that needs to be heated, you know, just to kind of ease them into it. I think for high schoolers, though, it's a little bit more open to interpretation because they've already been exposed to those concepts. So, yeah. Jessica.
Oh, maybe. Well, this isn't really a question, but to sort of add to your project, what if you did, like, at the end, you kind of ask them, well, okay, even though you do leave it open for them to kind of do it the way they want, what if at the end of the project you kind of ask them, aside from your discussion questions, like, how would do you have a more efficient way to do the same project with the same materials, but with, like, different tweaks? Like, I don't know, is there anyone in the class who can think of, I don't know, like a super efficient oven that just, I don't know,
So that was something that I tried to integrate into the lesson itself, is that there would be a timer. So we would start the timer and it would just keep going until the s'mores actually melted. So once your design was completely ready, you set up the graham crackers, the chocolate and the marshmallows and put them all together, and you set them in your oven and you would start the timer. So what I felt would be the most efficient, obviously, would be the one that took the quickest time to. So I tried to kind of integrate that into the actual lesson. So not only would it be a little bit of a competition, I mean, everybody would get a reward afterwards because they have the s'mores, but not only would it be a little bit of a competition, but we would also be able to see, you know, this took the least amount of time. What about this design was different from the rest that made it take a less amount of time?
Good question. That's it. So there's a learning moment for your students. What made it more efficient? That's a really good question. Jessica, were you talking about like sort of the other category question where you say, how else could you use solar energy to heat up a s'more? Like, and somebody says, magnifying glass. Or
yeah, like how do you, I guess you would have to add like different materials. Like how could you take these materials? I was thinking about Oreos.
sounds like, yeah, because it's like a snack.
Or like Cheerios or something.
Yummy. Are we having materials for lunch?
We are.
Oh.
Okay, hold on, I gotta bring it back. Okay. How would you add like other materials or take some away, just using the same basic foundation, like the homemade oven, but what else could you use to make an even more efficient oven?
What else could you use? So like add or
like Mr. McAlpine was saying, just what if you added a magnifying glass? Would that enhance the already efficient oven?
And why?
So post-activity discussion questions. How would you do it differently? What other materials might you use?
Yeah, my conclusion was just kind of, because I remember, I don't know if the rest of, like, you guys had this in middle school, was that for the conclusion, sometimes the teachers would say, write a general conclusion. But they would also add in certain questions, like the ones that I had, like what worked, what didn't work, that type of thing. So what do you wish you could have done differently in this experiment might have been something, you know, what do you wish you could have added to this experiment to enhance your experience, or something like that. I feel like if you give the students the opportunity to kind of like think outside the box and understand maybe what could help them or what could benefit them in terms of this project, then they'll probably absorb more, because it's the associative learning. It's,
I'm sorry, I started thinking about materials.
Materials.
Okay.
Good. Other questions or comments that you have on this?
Well, the question was, how would you assess your students' learning, which you answered by the recording the time of how long it takes for the s'mores to cook and everything. So how else would you grade your students?
So I think beyond that, it has beyond just timing it and trying, because some students can just be really creative and just somehow think of a really good idea that their s'mores just heat up quicker. So the way that I felt that I should assess them the most is through the conclusion. So the conclusion actually served as a large basis for how I would be able to understand how much the students actually understood. So in those questions that I would have, like what worked, what didn't work, what do you wish you could change, and just like continue with that. One of the last questions that I had was, I believe, it was what conclusions can you draw about the possible effects of dark spaces in aluminum foil? So what do you think the relationship is scientifically? So that would be something like Ms. Shafi said, if you were to tailor it to middle schoolers, then you would have to explain to them that photons or light particles will bounce off of the aluminum foil. And if it hits something that absorbs the heat, then that surface will become hot. So something like that. And then have the students be able to reproduce that. And then maybe explain why their design employed those concepts.
Let's talk a little bit about sequencing, where this would happen, let's say, in the semester. Had they already learned about the scientific method?
Yeah.
And how are you going to have them equate the scientific method? Are they going to make any hypotheses about what's going to happen?
Yeah, I was thinking more structurally. If my design were to use a basis of cardboard, then this would happen. If my design were to use more aluminum foil, then this would happen. Something structurally that would be able to say that. But that goes back to the whole timing issue. Something structurally that would be able to say that if I were to make a device in this particular way, would my s'mores heat up quicker? So that's essentially like the idea is how are you going to use all the materials provided or all the materials that you need to make the most efficient solar oven that you can.
Are you worried about with the competition? And I think the competition is really great. Why is competition a good idea overall? What is adding the dimension of competition, who can get this done first, add to the exercise? Ashley?
Motivation.
Motivation to do what? To win.
Yeah.
Okay. Erica?
I would say it adds a little bit of urgency.
Urgency, that's a good word. Urgency in the classroom. Good. Are you worried then that the student who wants to win most is going to say their s'more is done before it's done? How do we know the s'more is done? Is there some instruction about
That was another thing
when the
that I had.
marshmallow hits the black paper?
That was another thing that I had actually. There is a little. When I did this experiment, my teacher had. It was this thermometer that was like a pull thermometer. So the bottom of it was where the thermometer was, and the top of it had a little bit. It had a little handle where you could read what the temperature was.
Yeah.
And if there was a rule, I don't even remember what the degrees was, but for the particular type of chocolate that he got and the particular marshmallows that he got, it said he had done like research on it before, and it said that if it reaches this temperature, then your s'mores are ready. And you can start to see the chocolate seeping out of there. So if you were to use that the pull thermometer and stick it into the device, it takes the temperature from because heat escapes from surfaces. So it will take the heat from the device, and it
You get
uses
core
the surrounding
temperature
heat
reading.
in order to record the temperature.
Kind of like you use at Thanksgiving to see if your turkey's ready. I
Right.
mean, like it measures the inside temperature, not the exterior.
Right.
Oh, that's good. Okay.
Yeah.
So you have a quantitative measurement.
Mm-hmm.
May I just also say that I think one of the great things about competition is we focus a lot on competitive things in terms of athletics and not in terms of intellect. And I think it's such a great thing to really encourage that as well as something that's important to strive for, and that there should be accolades in that as well as just as there are in other endeavors that are competitive.
That's a really good point. And as a footnote to that, there's the Baltimore Museum of Industry does all these engineering challenges where it is a competition from second grade up through high school. I think the first one they do is everybody gets the same piece of paper who can fold the paper airplane that flies farthest and straightest. They literally build this is huge warehouse down on the harbor. They build a landing strip and they measure, so they have a competition, mainly design challenges. So I agree that it's really great to have intellectual competition in a fun way.
Yeah,
with,
I mean,
with a
and I
sweet
think,
payoff.
and I think adding that extra dimension of you get a treat afterwards.
Yeah.
I mean, even the winner will get the treat, but everybody else will too eventually, so nobody's really left out.
Yeah.
You just get that self-satisfaction that mine won first. So, yeah, I think adding another dimension to it and saying that if you're able to do this, you'll get your s'mores first, kind of motivates the students even more, because, I mean,
Sort of like you asking if the coffee was ready this morning. Best coffee.
I saw it.
Is my s'more ready yet?
yeah, basically.
I like these words of urgency, motivation. Good job. All right.